2015 on measurement and unit, on dimensional unit. We're on dimensional unit. So the question here says the dimension of the universal gravitational constant is. So we are looking for the dimensional unit for universal gravitational constant. So um, first, I said that the key to knowing the dimensional unit of any quantity is to know how, the definition, the mathematical definition of that quantity. So here we are talking about universal gravitational constant, which come from Newton's law of universal gravitation, which states that the force between two bodies or two masses, the force between two bodies or masses is directly proportional to the product of the masses, m1 times m2, and inversely proportional to the square of their distance apart. So this is a variation now. So when we bring a constant of proportionality, that will be f will now be equals to m1 m2 over r squared. R represent the distance apart, the distance between the two masses, then times the constant k. So now this question is asking us to find universal gravitational constant, the dimensional unit for it. So this is our universal gravitational constant here, k. So we are first going to make it the subject of the formula. If you make k the subject of the formula, k will be equals to, here r is on the denominator. So if you do cross multiplication, f here will multiply with r. So that will be force times what? R squared. And then since this one is on the numerator here, if you divide both sides by m1, m2, here will be that divided by m1, m2, making k the subject of the formula there. So now we've successfully made a gravitational constant the subject of the formula. So what we are now going to do is to derive the dimensional unit for this constant. So let's start. Dimensional unit for force. Force is a derived quantity. So first I'm going to split that of force. Force means mass m times what? Acceleration. Acceleration a. Okay, then times r squared. The dimensional unit for mass is m. Another mass is another m. So acceleration, the dimensional unit for acceleration is defined as what? Change in velocity over time. And velocity on its own is a derived quantity or a derived unit. It's a derived quantity. So velocity on its own means what? Displacement or distance over time, then divided by another time. So this will be distance divided by time squared. So the dimensional unit for acceleration will be what? The distance in its dimensional unit is L, is a length, over time is represented with capital letter T over T squared. So if we represent that here, we will now have mass times acceleration will now be L over T squared times r squared. R is a distance, so it's represented by L. Distance times another distance, that's L raised power of 2. Then divided by m times another m. M times another m. So if we proceed, this will now be m times L squared divided by m times m times t squared. This t here on this bottom here, according to where we process fractions, in which I have videos or tutorials on processing mathematical fractions or operation on fractions. So this T here will come down and join this one here. So now this M here will cancel one of the M here. So what is left is now L times L squared is L raised to the power of 3 divided by M times T squared. So if you take everything to the numerator, that will be M here is raised to the power of 1. So when it goes to the numerator, it becomes M raised to the power minus 1. L remains where it is, L raised to the power of 3. And T, if it goes to the numerator, it becomes T raised to the power minus 2. So the dimensional unit for universal gravitational constant is M raised to the power minus 1, L raised to the power 3, T raised to the power minus 2. So let's see which of our options lie with that. Minus 1, 3, and minus 2. Minus 1, 3, and minus 2, option A. So option A is the correct answer to that question. Thank you.